Alright, number one, we have a bunch of functions, and the problems are asking us to do what we call composition. So the idea here is we look in the innermost part, and so that's this g of 3. So we need to go to the g function, and we need to find g of 3. That means we need to do 3 squared plus 4. Remember, the idea there is I'm taking this 3 and I'm plugging it into there. And so, let's see, that comes out to be 9 plus 4, which is 13. Now we need to take that 13, and put it in the f function. So now it's going to go up into there. So now I'm going to find f of 13. Now the f function has 2 x's in it, so I'm going to use parentheses when I type that in for safety. Alright, so a little bit large numbers here. That's 169, that's 39, and 6. And you can grab a calculator at that moment. I already did this on some scratch paper. That's 214, I believe. Alright, so done with that problem. That's our answer. Letter B, g of h of 2. So again, we start with the innermost part, h of 2. H of 2 means I need to do 7 times 2 minus 8. That's 14 minus 8. That's 6. So now I'm going to find g of 6. And so, let's see, that would be 6 squared plus 4. That's 36 plus 4. That is 40. Letter C, h of f of negative 2. So you need to be careful on this one. The f function has a squared in it, and so this is really important that you put that negative 2 in parentheses before you square it with a calculator, because that negative needs to cancel out. Let's see, that would be 4 minus 6 plus 6. That all comes out to be just 4. So now I'm going to h the 4. I'm going to put the 4 into the h function. And let's see, that would be 7 times 4 minus 8. That's 28 minus 8. Final answer, 20. Letter D, g of f of 4. We're going to start with f of 4. Get that answer and put it in the g function. So f of 4 is 4 squared plus 3 times 4 plus 6. And that would be 16 plus 12 plus 6. That's 28 plus 6. That's 34. Okay, now I need to g that number. So g of 34 is going to be 34 squared plus 4. That's a large number. 34 squared, calculator says, is 1156. And then I need to add 4 onto that, so it looks like we're at 1,160. Okay. Oh, sloppy, sorry. That's the end of those. Alright, now number 2. We have basically the exact same situation. So you can see these definitely are on the ACT. So looking over here, we need to first find h of 2, get the answer to that, and then put it into the g function. So here we go. H of 2 is going to be 2 cubed plus 2. And so that's going to end up being 8 plus 2, which is 10. Alright, now I need to g that number. G of 10 means I need to find 2 times 10 plus 3. That's 23. That is the final answer. And there we go. Letter C. Each side of the smaller square in the figure below is x inches long. We can see that on the picture. that little square right there is x by x. Each side of the larger square is c inches longer than a side of the smaller square. The area of the larger square is how many square inches greater than the area of the smaller square. Essentially, we need to write one algebraic statement for the length of the big square, and that would be x plus the unknown number c. And this would be the same side length here, x plus c. It's just all there is to it. One thing I want to caution you on, just in case you were thinking of it, this big square is not 4 of these small squares. That's not what they're talking about at all. We have no idea how long C is. We don't know if this picture is drawn to scale. However, in fact, you can actually see that C seems to be a little bit longer than X, if that's any help. Anyways, so the side length is X plus C. Remember that the length of the area of a rectangle, or is length times width. This is a square, so it's side times side. So area equals side squared, and so the side length is x plus c squared, and that's exactly this answer right there. Alright, number 4, the graph of a certain hyperbola, which is this crazy graph down here. We haven't studied those yet, but we will. The equation is y equals h of x. In other words, we have no idea what the equation is. Doesn't matter. It's shown in the coordinate plane right there. So we have this graph. Among the following graphs, which best represents y equals negative h of x? So this problem is all about the negative right there. And we have studied that before. That means it is a reflection over the x-axis. That's all this question is asking you about. Anytime you take a function and put a negative in front of it, you will flip it over like a mirror from top to bottom. And so basically, this line right here would curve up to there then. That's the reflection of that. And then this one would curve down to there. And you can see that that is this answer right there. Done.